know how to do it by now if you've purchased it in MindTap. Jeremy, did your grade ever trickle back into into Canvas from the quiz you took? I remember you took one and it wasn't showing up yet. So if we go look into Unit 2 code, there's about 10 programming exercises. And what I'm going to do is I'm going to tell y'all that the more programming exercises you do, that'll be extra credit on your midterm or your final, just added directly to your score. And again, it's not letting me into it. This may be a very short attempt at getting into here. All right. It was in fact my cookie blocker. I thought I'd disabled it. So programming exercise 2.1. The tax calculator program of the case study outputs a floating point number that might show more than 2 digits of precision. Use the round function to modify the program to display at most 2 digits of precision. Below is an example of the program input and output. And there may be programming exercises that I make for a grade, but not from Chapter 2. So it asks for the income, enters the number of dependents, and then it calculates and displays the income tax. So if I wanted to, I could just copy that, all of that, and go in and paste it into idle just to take a better look at it. Here's our code. What does it do? It sets a tax rate up at the top, and it declares it as a constant, or what should be treated as a constant because it's in caps. Requests the inputs. We're using float input and an int input because number of dependents is supposed to be whole numbers. I'd argue that you could still use a float just because it'll crash if they type in 1.0 dependents, but hopefully nobody is stupid enough to do that. What's this thing here at the end of this line do? That backslash. Anybody recognize what that's doing? I'll give you a hint. It's not a math symbol. What it's doing is it's allowing us to continue on to the next line, right? Because this is more than it'll comfortably fit on one screen, especially in C-Engage, where you only have like, a third of your screen devoted to your code. So in order to go to the next line, most programming languages would let you do that. Just hit enter, maybe tab and keep going on your merry way. If you put the backslash there, that means, oh, there's more coming up on the next line. It just tells the compiler that these two things are actually part of one line. And then display the income tax. There should be something down there at the very bottom that I'm probably not seeing. Here we go, right? And so the income tax is that. All right, the problem is that it needs to be rounded to 2 decimal places. So what they're wanting us to do is to use the round function to add 2 places after the decimal point. Let's see what happens when we run it right now before we make any changes to it. I'm going to press the blue arrow here, enter the gross income, enter the number of dependents, and there's my income tax. Now that showed only 1 decimal, but is there a way we can run it to where we would get okay. So that's pretty lame, and we'd like to modify it so that we see only 2 places. Now what they're suggesting is using the round function, which we demonstrated last time. My preferred way would be to actually modify the output. But anyways, after we've calculated the income tax right there, we can round it. So on line 35, I'm going to modify it. Income tax equals round, parentheses, income tax, capital T, comma 2. Which means preserve 2 digits after the decimal point. And then run it again. So, gross income, I'm going to type in a whole bunch of decimal points just to make sure that the output would look pretty goofy. But in fact, it did display only 2 decimal points. The reason I wouldn't use round for this solution myself is that if it was an even number or with only 1 decimal point, it's not going to display it as .00, right? Let's see if we can get that to demonstrate. I'll run it again. I'm just going to type in 0 there, 0 there. And you see what I mean? Usually when we see dollars and cents, we like to see 2 places after the decimal. And right now we're only seeing 1. But if I make the change to actually make it always show 2 decimals after it, then, or 2 places after the, I'm botching that nomenclature up. I think everybody understands what I mean, but I'd like to get the more precise one. So if I click tasks over here, right? Here's the instructions for it. If I click tasks, and I click the checkbox, it tests it. See, it tested it with that amount and 1 dependent, and it tested it with that amount and 2 dependents, and it tested it with a 3rd case for 3 dependents. And if we click on this arrow, we get more information. Here was our input. We entered that number, and then this is the output that it printed. So we passed the test. Submit 100%. Is anybody who's actually in MindTap trying to edit this, did you get that to work? Hopefully you saw the change that I made. 1 line of code after we calculate the income tax. Right there. I just added it to line 35. Working for y'all. So let's take a look at the next one. So if you're itching for Python practice, strongly recommend you come and run through these. All right. Yep. Comma 2. All right. We misspelled a few things on that. Move this back up against here. I'm going to take one of those out. I'm going to make this a capital T, just because they have to match perfectly. Same business here. And it worked. Passed all the tests. So going to programming exercise 2.2. You can calculate the surface area of a cube if you know the length of an edge. So the program that they're going to give us asks for the cube's edge and asks for the surface area. The surface area is 96 square units when they typed in 4, because 4 times 4 times 4, right? Times 6, because there's 6 sides of the cube. So, write a program that takes the length of an edge as input and prints the cube surface area as output. See, they're being a jerk like I am and not giving us a formula for calculating the surface area, but we could look it up. But I'll just tell you that it's 6 times the surface area of a single side. And the surface area of a single side is edge times edge. So here's what they want us to let them type in. Exactly that. So to get this going, I'm just going to use some copying and pasting right here. I'm going to copy that. And I'm going to come over here, and that's going to be my input statement. Edge equals float, parentheses, input, parentheses, and inside all of those parentheses, I'm just going to put a pair of double quotes, and inside there, I'm going to press paste. And there's my prompt, right? That's the prompt that they're going to be presented with. Now we need to calculate the surface area. So, area equals edge to the power of 2, or just edge times edge. So EDGE star star 2, but that's only one side of the cube. So then there's 6 sides to a cube, so times 6. So grading, when you've completed your program, click the Submit button to record your score. Well, I haven't printed the result out yet, and here's how they want my result to look. So again, I'm going to do some copying and pasting to make sure I get the exact output that they want, because I don't want them to count me wrong because I didn't put a period here. Whoops. So print, parentheses, double quote, paste that, the surface area is, end quote, and after the end quote, comma, we need to print that variable, area. So comma, area, comma, and then we need to print the rest of this message. So after the area, comma, I'm going to copy, paste this, and put this in quotes as well. Now I'm going to run it, see if it works. Enter the cube's edge. Well, if it's a 1 by 1 cube, then it'll have a surface area of 6. So as far as I can tell, my program's running correctly. Let's see if MindTap agrees. So once I've entered all my code, I'm going to come over here and click on Tasks. And I'm going to click the checkbox to ask it to run it for me. Three out of 3 checks passed. Great work. Okay. You know what, if we're going to the effort of getting these, we may as well mark these for a grade if I can go back and do that at this point, but I'm not sure that I can at this stage of the game. Let's find out. Oh, it did. All right, cool. Let's take a look and make so this way you're actually getting grade credit for it. Make sure 2.3 makes as much sense as the other two did. Okay, so if I'm going to do this one as well, or actually I'm going to assign this one as well. It's pretty straightforward. New videos cost $3, oldies cost $2. Our program is supposed to ask for the number of new videos, and then ask for the number of oldies, and then give us the total cost. So what's the pseudocode for that? Input new, input old, cost of new equals new times 3, cost of old equals old times 2, total equals cost of new times cost of old. So that's a good one. All right. Somewhat dubious that this one's going to work perfectly, but I'll make it for a grade as well, and then we'll stop with these. Let's take a quick look at 2.4 after I do this, because I want to remind you how to get the value of pi for you to use. So 2.4 requires pi. All right, the code editor is no longer working for me. Just about the time when I was starting to feel comfortable with line tap again. There we go. All right, if you need pi in your program, you could always just say pi equals 3.14159. I didn't see them specify what value to use. Looks pretty precise. Looks a lot more precise than just 3.14159. So instead, what we want to do up at the top is import the math library. And then let's just, to test it, make sure that import worked. We're going to print out math.pi. And there it is. So that's the value you would want to use. And if you don't like sticking math dot in front of your pi variable, change the syntax of this import statement to from math import pi. And then you could just print out pi, right? Like that. So give 3 and 4 a try. Not right now. I'd kind of like for you to, watch the lecture as we go. But give 3 and 4 a try. We'll see how MindTap's treating us this semester. All right, so we were essentially at the end of Chapter 2 because we'd hit the review. So, onward to Chapter 3. Feels low energy in here today. So I'll get up and do jumping jacks. Nah, let's not. How many people were hoping for more snow? Get to stay home today.
I take it for the coding assignments that we have more than one attempt for everything.
Yeah, more than one attempt, right. You can keep revising it endlessly.
Yeah, I'm just thinking. It's like Like, oh, I'll misspell a word and have it crash.
Yeah, you can always go back to it and it will maintain your last attempt. So if you close the browser and go back in it, then your code is still there to play with next time. Good question. No, I do not want you to update now. I'm sure that it would fail anyways if I tried. Okay. So, loops and selection statements. Looping is what computers are all about. You're playing a game. The only reason that the game works is because it's looping over and over and over and over, waiting for your input, getting your input, performing some calculation in its brain, and updating the display. That's all about how a game works, right? It's very, very rare that you would run a program just to enter one piece of data and then look at the answer and then leave. You'd grab a pocket calculator for that, right? I mean, and that's the kind of programs we're writing in here for the most part. At the beginning is get a piece of input, perform a calculation on it, display the result. But in the real world, programs are usually going to loop. You want to let the user repeat something over and over and over until they decide to quit. Surely I can get rid of that. Yeah, okay. So if you've taken a Java or C programming course, you've probably heard of while loops, for loops, and do loops. There's no such thing as a do loop in this language, so we can toss that one out the window, leaving us with only the other two, and that's fine because anything you could do with those two loops, you could do with the other loop, or vice versa. There's nothing you can do with a do loop that can't be done with the others. Sounds like a Beatles song. So there are two kinds of loops. Loops that repeat an action a predefined number of times, or those that perform an action until the program determines it needs to stop. A predefined number of times. You might want to write something that will print happy birthday on the screen 10 times, right? It's a predetermined number of times. You know it's going to print 10. Even if you ask the user how many times do you want to print it, it knows in advance because the user typed in a number, they typed in 100, and so it's going to print happy birthday 100 times. So that's a definite loop, or a definite iteration. And then there are loops that are called indefinite loops, or indefinite iterations. The program doesn't know in advance how many times it's going to run. It's just going to run until it determines it needs to stop. And when I say it determines it needs to stop, there's going to be some kind of user input, most likely, that says, you know, I want to stop here, or it's going to be reading from a file when it hits the end of the file, that kind of thing. So two different kinds of loops. Let's go to lecture F, I believe. All right, so two different kinds of loops. I'm going to just open up a multi-line quote. There are definite loops. The loop runs a specified number of times, or the loop iterates. Let's get all fancy. The loop iterates a certain number of times. And then there are indefinite loops. And when I say a certain number of times, I should say a predetermined number of times. Predetermined number of times. And an indefinite loop, the loop runs until, well, they had kind of a vague description here. Until it needs to stop. That is so vague. I'm going to see if I can find a slightly better one. An indefinite loop waits for some condition to become true. How about we just say, the loop runs until a condition becomes false. You're playing Pac-Man. You keep getting to play Pac-Man until the number of Pac-Man lives becomes 0, right? And then you keep being able to restart the game until the number of quarters you've put in has become 0, the number of credits, right? So it keeps running until a condition becomes false. Let's do an example of each. A definite loop might look something like this. For x, for space, x space, in space, range, parentheses 10, in parentheses, colon, hit enter. It should be indented now. Print parentheses x. This is a definite loop. I'm going to add a comment to that effect. An indefinite loop, let's skip on the indefinite loop for now. That's definitely an example of a definite loop. It's going to run a predetermined number of times. We knew that it's going to run 10 times. That range statement, what is a range? It starts at 0 and it goes up to but not including 10. Well, that's funny. Why did it start at 0? Just because it does. If you want it to start at a different location, you put a number here. If I wanted to count from 1, I would put 1 comma there. Now it's going to count from 1. All right, so it ran from 1 to 9. But I said 10. Well, yeah, that's just a quirk of the syntax. What this range statement does is starting at this number and going up to but not including that number. So it's inclusive on one end of the range but exclusive on the other end of the range. If we did this, x equals 1, and then while x less than 10 colon, print parentheses x, we're going to see identical output. Or not. I made an infinite loop. Somebody tell me what I would have to do to fix that. It's just printing 1 over and over and over because of this code.
You have to count 1 up.
Yep, I forgot to update the variable. If you have a loop written like this, a more indefinite kind of loop, and you forget to update the condition that could cause this to go false, it'll never go false, and so it will repeat endlessly. So here I need to do x plus equals 1, no space between the plus and equals, which is the same as typing x equals x plus 1. I'd like for us to get in the habit of saying x plus equals 1. Now to work. All right, so that's a definite loop. We absolutely knew in advance it was going to count from 1 to 9. This is an indefinite loop performing a definite purpose. What do I mean by that? Since the math involved is predictable, the results are predictable. But it ran from 1 to 9 because it only kept running while x was less than 10. If we change that to x less than or equal to 10, we'll see it count up to 10. Like that. The reason I did it is just less than 10 is because I wanted it to mimic this behavior exactly to show you why when you put a 10 here it only counts to 9. It's because it's going only while this counter is less than that value, not less than or equal to. Now when I write a while loop on my own, the way I think is, I'd like for this number to specify the end point, right? Not one past the end point. So if I hadn't been writing to duplicate this code and I wanted it to count to 9, I would have made it while x less than equal 9, right? Because that's the way my brain works. But I did it this way because I wanted to count from 1 to 10. So definite loop counts 1 to 9. And this is also, I'm going to call it an indefinite loop even though it has predictable results. Counts 1 to 9. So the syntax for these is always that you have a loop header statement here, followed by a colon at the end, and then everything that's indented underneath the loop header is called subordinate to. Everything that's subordinate to the loop header is tabbed over. And it keeps repeating this statement or this block of code until the condition becomes false. Or in the case of a definite loop, a for loop, running through that series of values, and then it exits when it's reached the end of its series. So I just watched a video this morning showing that the summation of all numbers from 1 to infinity is equal to -1/12, which is absolutely insane to think about. Let's write a summation that will just add up all the numbers between 1 to 100. So in order to get a summation, we're going to need a total variable so that we can start adding on to it, right? We're going to start total off at 0, and then we're going to add 1 and 2 and 3 and 4 and 5 and so on to it. So total equals 0. Why don't we ask the user for the number to sum up to? Now this is one of those cases where if I was going to use a range statement, I would have to use an int. Normally I say that you can use float just about anywhere and it'll work the same, but these two values here have to be integers. So if I typed in 10.0 there, it would break that statement. So when I ask for this input, I probably had better convert it into an int. So I wanted my variable to be called max, and so I started typing max, and then it lit up this purple, meaning that max is already the name of the function. So I'm not going to use that. I need to come up with another. How about end, for like end point, or limit, right? How about limit? Limit is equal to the int parentheses, input parentheses, a pair of double quotes followed by 2 closed parentheses, but inside those double quotes we're going to ask our message. Summation to what value? Question mark. Space greater than. Now that we have a limit, we can write a for statement that'll count up to that value. And let's just do it as a while though, because I feel like doing while. Let's say while the limit is greater than 0, while limit greater 0, add that limit to the total. Total plus equals limit, and then remove 1 from the limit. So limit equals limit minus 1, or limit minus equals 1. Hyphen equals sign 1. So what did I do there? Well, if they type in 10, we're going to add 10 to the total. Then we're going to subtract 1 from 10, and it's going to be 9. We're going to add 9 to the total, and we're going to subtract 1 again. We're going to add 8 to the total, and we're going to keep doing that while that limit variable is greater than 0. Once it hits 0, we don't need to add it to total anymore. And then we can print our output. Sum equals, end quote, comma, total. Make sure it works. So down here at the bottom, it's asking me summation of what value. I'll bring the code back in a second. I want to sum up all the numbers between 1 and 10, and it's 55. And just from prior experience, I know that that happens to be correct. What happens if we type in a much larger number? I'm going to run it again and say that I want the summation of all numbers from 1 to 1,000,000. So 1 followed by 6 zeros. 1, 2, 3, 4, 5, 6. and it runs really quickly. Computers are fast. What they're not fast at is updating the screen. If I had put this print statement indented here, it would be part of the while loop. It would be subordinate to the while header. It would repeat every single time, and so I would get a million print statements. I'm not going to really like the results. I mean, maybe it's fun to watch. Alright, but it's obviously going to take a long time to complete. So if you're doing a lengthy calculation, having this kind of scrolling output is a bad idea. Updating it once per iteration is a bad idea. And then you could try to work on something like, well, maybe it'll only display the, an update once every 100 iterations or something like that. But for this part, I just feel like fixing it so that this does not repeat every time. And to make sure it doesn't repeat every time, do that. So Python's for loop is the one that most easily supports definite iteration. For each pass in range 4, print it's alive. And so it prints it's alive, it's alive, it's alive, it's alive. They've thrown in a new twist here. Well, for one thing, they capitalize a P there, which would not work. But check out this end equals business. Let's use that in one of our examples. Come up here to this print statement, this very first print statement. Add comma after the X, and then say END equals double quote dot 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 in double quote. And then underneath that, back tabbed all the way against the margin so that it's not part of the body of the for loop, just do a print. Or if we feel like it, put a print, double quote, exclamation mark, in double quote. So I'm going to run it, and I'm going to bring the results up side by side with the code that generated that.
That should be horizontal.
You see what it's doing there? This end prevented it from going to the next line. This print statement caused it to go to the next line every time, right? On our second loop, it's going to a new line every single time. That's because this built-in end parameter defaults to \n, which means go to the next line, right? And so now it went to the next line at each one because I told it to. So if I did not have that end parameter there at all, that's the behavior that I get. But if I specify an end parameter, a value for the end parameter, it does something different. So now, instead of going to the next line, after it prints out X, it's just going to print space dot 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 in space and then stay on the same line. So why did I put that print underneath? Because eventually I wanted it to go to the next line, right? Otherwise, the output from the second loop would just have started off right there. It would look kind of dumb. Improve that by commenting that out. So when I run it, see it printed 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it printed 1 here, which is not what I wanted. And that's because nothing ever printed out a new line character, a \n character. So just to get that to happen, I did that. If I don't feel like making it an exclamation mark, which normally I wouldn't, I would probably just print an empty string like that to make it go to the next line. So when you're doing one of the MindTap programming problems, you have to match exactly what the output that they're trying, which is why I was trying to do copy and paste from their specifications into the code. In my code, I never specify exactly what it has to look at. Like, I might give you sample input and output, and I want you to make it look kind of close to it. But if you word your questions differently than I do, right, or you punctuate differently, or you insert extra blank lines or stuff like that, I'm not going to count it wrong, because what matters to me is that you know the process, the logic, and how to get some output, not that you can match every dot for dot that I've got in my sample output. Unfortunately, the MindTap's not quite so generous. So something else I want us to look at a different site, different website. This one's called Coding Bat, like a bat or animal with wings. Go to coding, coding, bat.com. And click on Create Account. And honestly, you can type in anything that you want here. Right. Doesn't even have to be a real account. As long as you memorize what it's going to be, right? I could say that I am Trump at whitehouse.gov. I'm not going to do that, right? And it would let me in, right? But if you ever wanted to log in later, it'd be a good idea to at least remember your password. Yep, so codingbat.com. And you could, I would suggest going ahead and just using your radar.rom, radar.rose.edu email address. All right. So what is this site? It's a site full of programming problems, which you can do either in Java or Python, which is pretty cool because after you write all the answers in Python, you could try to come back and learn Java to rewrite them, and you're kind of learning two programming languages at once. Now, we're not going to do that. But I'm going to click on Python and go into Warm-Up 1. All right, these are nice because solutions are available to these. So here's a problem called sleep in. I wonder what the H means next to it. Anyways, sleep in. And it's telling us the parameter weekday is true if it is a weekday, and the parameter vacation is true if we are on vacation. We sleep in if it is not a weekday or we are on vacation. Return true if we sleep in. So what in the heck is that telling us? Well, what they have done is they have given us the first line of code, which is a definition for a module. And their code is going to call that module, that function, and based on the input given in, fed in to these parameter variables, we need to return the correct value. And so I get to sleep in if it's a weekend, meaning that weekday is false, and I get to sleep in on vacation. So here's what I'm going to do is down here after the colon, tabbed over one, right? I'm going to check if vacation equals capital T RUE, if vacation equals true, return true. Again with a capital T, and this is indented under the if statement. So here we have one indentation, here we have two. All right, I'm going to pretend that I think that that's the answer, and I'm going to click go to watch what happens. And it didn't pass all the tests. If I come over here and look, it failed 2 times. I could figure out under what conditions it's failing. Weekday is the first parameter, vacation is the second parameter. So if I come and look over here, it failed to take into account weekdays. Because whether weekday was set to false or true, it got the wrong answer. And that's true. All I did is check for vacation. Well, let's check for weekday. if vacation equals to true, or, put the OR there, or weekday equals capital F false, then return true, because those are the circumstances when we get to sleep in late. If the vacation is true or if the weekday is false, meaning it's a weekend. But it has to return something if that stuff isn't true. Right now it's returning, quote, none, if those things aren't true. That's why we see in this little run category column that sometimes it returns true, but sometimes it returns none. Well, that's when I need my else statement. So over here, I'm going to add else colon, return false. And this else needs to be lined up with the if. So it's just one tab in. Now, we're not really at the point where I expect us to have been writing functions yet, right? So I'm not going to assign us homework yet from coding that.
Does your false need to be capitalized?
Yes, it does. Why is this not blue? Because I forgot to capitalize false. Because false is only capitalized in certain languages, not in the other languages I teach, C# and Java and stuff like that. All right, so now we run it. And we got correct input. It's green all the way down. So when I go back to click on warm-up 1, it shows me that I did solve that problem correctly. I'm going to leave that alone. We're not going to do any more on that. I'm going to wander around for anybody who was trying to get that to work, to make sure that you got it to work. So if you have a range statement, okay, anyways, that's what the END equals quote space quote did right here. It printed out it's alive followed by a space rather than go to the next line. So the general format of the loop is for with a lowercase f rather than an uppercase f. I really need to remember to upload these back once I make all these edits. For variable in range, and then in parentheses there's some other kind of integer expression. Usually just a number that you've hard-coded or a variable like x. And then the statements that need to be repeated over and over are tabbed underneath the for loop. So this is called a loop header. The rest of it, everything that's indented underneath it, is the loop body. And it has to be aligned in the same column. One of the easy mistakes to make is just to indent one of these things wrong, right? Like if I put that there, it looks good to me. Doesn't look good to the computer. It's a quirk of this language that since they don't use braces to denote opening and closing code, that the indentation has to be perfect. That's why I like braces, but Mr. Java, excuse me, Mr. Python, I never can remember his name. Didn't. So here's the loop to compute an exponentiation for a non-negative exponent. Now this is the exact same code we did, except they're calculating. It's the exclamation mark on your keyboard, on your calculator key. So it's 1 times 2 times 3 times 4 times 5 times 6 times 7. And so rather than adding each time, they're multiplying each time. And they're printing out the intermediate results as it goes along, which I didn't do, right? I had that back tabbed over on my print so that we only got one piece of output. Same line, right? I mean, same thing. I would not have used that variable name. That seems a little bit too precious. But yeah. For me, if you have a variable that's just stepping through a range of values, it's okay to use a single letter variable name. I is a good one, right, for iteration. For I equals, or V for value, for every value in this range. So a loop that counts through a range of numbers. I'm surprised that this was not the first example. Well, that doesn't count through a range of numbers. It's still calculating the exponentiation. So that does not match the comment. And that's actually a very, very common problem. When you're working in a team, somebody will add a comment, somebody else will go in and modify the code without modifying the comment, and then the code and then the comment is in effect lying, right? You know, something has changed, the comment wasn't changed, and it can actually be a problem in code, because usually what the comments are for is to give you a simple offhand description of what the code is doing, and if they're lying to you, then you're not going to understand quite what the code's doing. So here's summation instead. All they did is use plus. When I did it, I showed you how to use plus equals instead, right? Plus equals. Otherwise, that's the exact same code. Augmented assignment. Other textbooks call this compound assignment operators. Instead of saying A equals A plus 3, you can do A plus equals 3, and it does the same thing. It adds 3 to A and stores it back into A. It's just a shortcut. One thing that I miss in this language that other languages have is if you're going to add 1 to something, an awful lot of languages just support plus plus as a way of adding something to it, adding 1 to it. If you ever see A++ or C++, it's even the name of a language, then what it does is it takes the current value of A, adds 1 to it. It's called incrementing. If you're going to increment a variable, it means to increase it by 1. If you're going to decrement a variable, it means to decrement it by 1. However, this language doesn't do that, so instead you would do that. That's an increment by 1. Minus equal is decrement by 1. So loop errors, off by 1. We think that this is going to count from 1 to 4, but it actually only counts to 3, because the upper bound is a less than, not a less than or equal to, and that's just how for range works. There's no way to customize its behavior so that this exactly specifies the upper bound. It's exclusive on the upper end. I believe that's the correct math term when you're talking about a range, and it's inclusive on the lower range. Let's play with a couple of more for loops just to make sure that we totally have the idea. So I'm going to go back. I'm going to keep flipping around, huh? For x in range, starting at 10 and going up to but not including 21, colon, print parentheses x, comma, quote, end equals, wait, get rid of that quote, my mistake. End equals, quote, space, quote, in parentheses. And since this is all going to be on the same line, do that end parameter, I need a print here to go to the next line at the bottom. So unindented from the body after the for loop. Okay, so it's going to count from 10 to 20. That's the whole purpose of that. 10 up to 20, because the upper exclusive bound is 21. Now copy those 3 lines of code, and we're going to change the for loop parameters just a little bit. I'm going to add a comma 2 there. This is the increment value. The increment value by default is 1. But if you specify an increment value, it goes up by that. So it's going to go 10, 12, 14, 16, 18. So I'm going to add a comment here. Counts 10 to 20 by 2s, right? 2, 4, 6, 8, 10. Well, 10, 12, 14, 16, 18, 20. This up here counts 10 to 20 by 1s. What if you wanted to do the same thing with a while loop? Now, I like for loops. They're very concise. Everything you need to know about the range is specified in one line. If I'm going to use a while loop to do the same purpose, it's a 3-step process. The first line of code has to be to declare my loop variable. The second one has to have the condition. And then underneath the body of the code, there has to be an update to that variable, just like this, right? It was a three-step process. I needed a counter called limit. I needed a condition to check it, and then I needed an increment, which in this case was actually a decrement, right? So where this thing specifies all that in one line, a while loop will do it in three. All right, so let's just set a variable, doesn't matter what it is, x, I, v, equal to 1, or no, 10. Let's start at 10, just like that other loop did. And then while x, and here you get to do how you feel. Do you want to do x less than equal to 20? To me, that looks better. If I'm counting from 10 to 20, I like to see that. Or do I want to mimic that range statement precisely and just make it while x less than 21? I think I'll leave it like that. No, I can't help it. I like this other one so much better that I'm going to make it while x less than equal to 20. So tabbed inside the while loop, let's print parentheses x comma end equals quote space quote in parentheses. But we're not done yet because we have to update the loop variable or it's going to be an infinite loop. I mean, I can prove that just by running it. Right. Bad news, because I did not update the loop control variable, so this expression here never became false. So x plus equals 2. I'm counting by 2's. If I wanted to count by 1's, I would make that x plus equals 1. And then unindented, all the way back against the end of the margin, the edge of the margin, I'm going to print nothing. Just kind of like hitting the enter key when you're typing. Dot, 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 hit enter. Go to next line. So this also counts from 10 to 20 by 2's. That's why we see identical output. So I'm going to add a comment here. Count 10 to 20 by 2's. Note how much cleaner it is to do this with a for loop, right? For loop just took 2 lines of code, not counting the final print. This one took 4 lines of code, not counting the final print. Nothing wrong with doing a problem like this either way. All right, how about one more example where we're counting down, right? Make the rocket lift off. But let's do a for loop because, as I've been saying, the syntax is cleaner. For x in range, parentheses, we want to start at 10, so it'll go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 10, comma, 0. We're going backwards, so I'm going 1 past. I wanted to stop at 1, but this has got to be 1 past that, right? Just going the other direction. So 10, comma, 0, and please subtract 1 from x each time you go. 10, comma, 0, comma, minus 1, end parentheses, colon. It's about time to do one more walkabout and then do homework, create a homework assignment. So one more time, print x comma end equals quote dot 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 end quote in parentheses, just to kind of, you know, vary up, change things up. End quote in parentheses. On the next line, unindented, back against the margin, let's say we have liftoff, exclamation mark. I read in Gizmodo, that very reliable website, that Space Force, the new, you know, branch of the military, just sent its first missile off, and I'm wondering, it said that it's nuclear capable. We already have nuclear capable missiles in our arsenal. So if I'm understanding this correctly, this is probably something that would send a nuclear missile up into space, perhaps to, you know, try to take down another spaceship or something like that. And that's definitely against treaties in the past, but I think that those treaties have been declared void by both sides. Alrighty, so anyways, now when it counts down, we should see it say done something wrong. Let's run it again. Summate to what value? All right. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have liftoff. So let's add a comment as to what that is doing. Count from 10 down to 1 by minus 1s. And you can assume when you say down, right, that it's by a negative value. All right, homework. Let's come up with some homework, then I'll walk about. Homework. Write a script that counts from 1 to 30 by 1s, then counts from 32 to 60 by 2s, then asks the user for a number and counts down from that number to 1. And when I say count down, you know, it's supposed to use a variable and print the result of that variable. You can use for loops, you can use while loops. I'm not going to specify. I'd recommend using for loops, just like I said, because it's easier, and now you have a lot of examples of that. So the other bit of the homework is do coding problems 2.3 and 2.4. Now, just because I went into MindTap and marked those problems as being worth credit, I have to go back into Canvas and say, yes, those things really are worth credit. And then you're going to have to go through and submit them again if you've already done them. So as soon as class is done and I go and add those things into Canvas, I'm going to ask you to go and resubmit 1, 2, 3, and 4. Right? Submit them all so that all the grades show up in Canvas. Also resubmit, you know, recheck problems 1 and 2. So they grades export to Canvas. All right, does that make sense, gang? Anybody have typos that you wish to go away? Let's make the Dropbox so we can get out.